Jai Hind. Today we are going to discuss the corona effect on transmission line. Okay. So basically, what is corona? Corona is basically, in terms of transmission line, it is a ionization of air molecule around the surface of the conductor. Means if we are having a transmission line conductor, then there is air surrounding the conductor and they gets ionized, and the energy of this ionization is supplied by the source. Okay, so this is basically a electrical discharge, as we can say that it is a electrical discharge. So as here in a uniform electric field, a gradual increase in voltage across a gap produces a breakdown of a gap in the form of a spark without any preliminary discharges. Okay, means whatever the breakdown voltage of the air, if the breakdown voltage, if the voltage of the transmission line is greater than that breakdown voltage of the air, then that air gets ionized. Okay, let's let the voltage, the breakdown voltage of air, that is 30 kV, and if operating voltage of transmission line is 40 volt, 40 kV, so in this case the ionization of air takes place, and this is corona discharge. Okay. On the other hand, if the field is non-uniform, an increase in voltage will first cause a localized discharge in the gas to appear at points with the highest electric field intensity, and this form of discharge is called a corona discharge. Okay. Corona discharge can be observed as a bluish luminance. It have a color. It have a lightish color, bluish. Its luminance is bluish. Okay, and this phenomena is always accompanied by a hissing noise. If you are going to the underneath of any high voltage, extra high voltage transmission line, you always hear a noise, hissing noise. So that is due to the corona loss. That is due to, whenever you are going, you just have a take a stand underneath of a extra high voltage transmission line, you just hearing by a noise, and that is due to the corona discharge. Okay, and the air surrounding the corona region becomes converted to the ozone, ionized, and whatever the air surrounding the transmission line conductors, they are converted to a ozone, and corona is responsible for considerable power loss in transmission line, because we know that this ionization of air, that is that takes power, that takes electrical power, and where from this electrical power came, that is from the supply system. Although what is the noise, what is the bluish luminance, these all includes the corona loss. Whatever the power that extra taking from the source, that is known as corona loss. And it also gives rise to radio interferences. It also increases the radio interferences in the transmission lines. The result of radio interferences, that is the unbalanced voltage, unbalanced currents, okay, that harm the system, that inject harmonics to the system. So these are the features of the corona. Mechanism of corona formation on a two conductor line. If you are having two conductor, when a gradually increasing voltage is applied across two conductors, here we are having two conductors and we are applying gradual increasing voltage. Initially nothing will be seen or heard. Okay. As the voltage is increased, the air surrounding the conductor gets ionized, as we have discussed. As the voltage is greater than the breakdown voltage of air, the air gets ionized. Air gets ionized. And at a certain voltage, a hissing noise is also heard, caused by the formation of corona. And at a particular voltage, at a certain voltage, a hissing noise is also there. And this is caused by the corona. And this voltage at which this hissing noise and this corona takes place, this is known as critical disruptive voltage, or we can say that disruptive critical voltage. Both are same. So this minimum voltage of a transmission line that can create the ionization of air followed by the hissing noise, means it is the voltage at which corona takes place. A voltage less than critical disruptive voltage is not responsible for producing corona, means there is no corona at less voltage critical disruptive voltage. When we are having the voltage that is greater than this critical disruptive voltage, then corona takes place. Okay. A further increase in the voltage would cause a visible violet glow. If you are go on increasing the this voltage of transmission line, then at a particular voltage, a visible violet glow around the conductors takes place. And this voltage is visual corona inception voltage or visual critical disruptive voltage, or we can say that visual critical disruptive voltage. So we are having two things: critical disruptive voltage at which corona takes place, followed by hissing noise. If we are increasing voltage more, then we found that at a particular voltage our a visible violet color is there, and that particular voltage is known as visual corona disruptive voltage. Okay. Mechanism of corona formation on a two conductor line that is continued. If the applied voltage is direct DC, the glow observed will be uniform on the positive conductor, while the negative conductor will be more patchy and often accompanied by streamers at rough points. Here the direct means DC. And in the case of alternating voltage, both conductors appear to have a uniform glow. So in case of DC, as we have seen that the glow observed will be uniform on positive conductor, while on negative conductor there will be more patchy and often it is accompanied by the streamers at the rough points. But in case of alternating voltage supply, both conductors appears to have a uniform glow. And if a voltage is further increased, the corona increases and finally spark over would occur between the two conductors. If you are going to increase the voltage in continuity, then at a point at which the disruption, this spark over is there between two conductors. The sparks takes place. And if the conductors are placed quite close together, corona formation may not occur before the spark over occurs. So it is more dangerous to have the two conductors too closely, because before corona there is a spark over there. So that is the fault. The formation of corona causes the current waveform in the line to be non-sinusoidal. It also creates the non-sinusoidal nature of the current. And to prevent the formation of corona, the working voltage under fair weather conditions should be kept at least 10% less than disruptive critical voltage. Under fair weather condition, we have to take the voltage at least 10% of critical disruptive voltage, but it is not possible in case of extra high transmission line, because we all know that if we have to transfer the electricity over very long distances, we have to increase the voltage of the transmission line because of the higher power transfer capability. The extra high voltage have a ultra high voltage have a very high power transfer capability. So we keep this corona, okay. But if it can be managed for a high voltage HVDC transmission, then we can manage and have at least 10% less disruptive voltage. But it cannot be avoided in case of extra high and ultra high voltage transmission lines. Corona formation may be reduced by increasing the effective radius. If we are increasing the radius of the conductor, it can be reduced. So means we have to use the bundle conductors. In case of standard conductors, we have to use bundle conductors. Then if we are using bundle conductor, it increase the overall radius of that particular conductor. Hence, corona will be reduces. Thus, steel cored aluminum has two advantages over hard drawn copper conductors on account of larger diameter and other conditions remaining the same. We can use ACSR, steel cored aluminum conductors. The effective conductor diameter can also be increased by the use of bundle conductor that we have discussed. Corona acts as a safety valve for lightning surge by causing a short circuit. The only advantage of this corona is it is a protector for a lightning. They absorb the lightning surges. So you can call it a safety valve for lightning surges by causing a short circuit. And the advantage of corona in this instance is that it reduces the transient by reducing the effective magnitude of the surge by partially dissipating the energy due to the corona. And it also reduces the peak of that particular surge, the peak voltage of the surge. So that is also the advantage of this corona. Mechanism of corona formation. If the voltage is high, the surface stress may reach a value at which the air breaks down and becomes a conductor. The conducting layer of air forms part of the conductor so that R increases and the maximum stress decreases. If the spacing is small enough for the corona to cease spreading long before it breaches the conductor, the value of R and E are reached such that the stress is insufficient to ionize more air. Under ordinary condition, the breakdown strength of air can be taken as 30 kb per centimeter. That is the breakdown strength of the air. Means that if you are having the voltage less than this breakdown voltage, we cannot create corona. That is the good. So for air, the breakdown strength is 30 kb per centimeter, and if it is maximum value, it is maximum value, and if we are converting it to RMS value, it comes maximum upon root 2, and that is 21.2 kilovolt per centimeter. And thus here it is. Thus, if E naught RMS is the RMS value of disruptive critical voltage to neutral, then this RMS 21.2, that is E naught RMS R log E D upon R, means we can say that E naught RMS, this is critical disruptive voltage, it is equal to 21.1 2 R log E D divided by R, where R in centimeter. Remember that the unit of R is centimeter, D centimeter, R centimeter. Is that clear? R is the radius of conductor. D is the spacing between the conductor. Spacing between conductor. As we can see that if you increasing D, the value of critical disruptive voltage increases, and if you are increasing R, the value of E increases. That reduces the corona. Okay. So corona will of course be affected by the physical state of the atmosphere in stormy weather. Okay, so it depends also. It also depends on the weather condition. Location of the transmission line, means it is hilly areas or it is on plain areas, fair weather condition or winter, stormy, that depends on the atmospheric condition. So in stormy weather, the number of ions present is generally much more than normal. In case of storm weather, the ions surrounding the conductor, they are more as comparison with the fair weather condition. Okay, and the corona will then formed at a much lower voltage than in fair weather condition, means critical disruptive voltage is having lesser value in case of stormy weather condition as compared to the fair weather condition, means corona takes place earlier. Okay, and the power loss will be more than in fair. This reduced voltage is generally about 80% of the fair weather voltage, means the critical disruptive voltage ED at stormy, that is 0.8 times ED at fair. Okay, and it also depends on the surface of the conductor. It is regular surface, irregular surface, and in case of winter season, the ice, the part of dust, the part of water on the transmission line conductor, that may change the corona. Although it is increasing, everything, if we are talking about environmental condition, then we can have corona minimum at a fair weather. In case of rainy, winter, any season, the corona will be more, and it is started earlier. When the surface of conductor is irregular, it is more liable to corona, and thus an irregularity factor M naught is also introduced to the account for this reduction. So M naught is the factor of regularity. Okay, so typical value for this factor are M naught equal to 1 for a smooth polished conductor. Smooth polished means that cannot contain any type of dust. If dust is there, then it is flash off instantly. Okay, 0.98 to 0.93 for roughened conductor, 0.9 for cables for more than 7 strands, 0.87 to 0.83 for 7 stranded cable. Okay, so this is the Since the corona formation is affected by the mean free path and hence by the air density, a correction factor delta, or we can say that del, is introduced. This air density correction factor is given by the usual expression, where P being the pressure expressed in torr and T being the temperature expressed in degree Celsius. Okay. So, this is a air density factor del and it comes 0.386 P divided by 273 plus T. So, we can calculate, means the value of del that depends on the pressure and temperature of the environment basically, and this del also multiplied in that particular means we can say that the disruptive critical voltage can be written as this one, 21.1 del m naught r log E d upon r. Okay. And the visual corona occurs at a higher voltage than the disruptive voltage. For the formation of visual corona, a certain amount of ionization and the raising of electron to an excited state are necessary. The production of light by discharge is not due to the ionization, but due to the excitation. That is the main thing. And the subsequent giving out of excess energy in the form of light and other electromagnetic waves. To obtain the critical voltage for visual corona formation, the disruptive critical voltage have to be multiplied by a factor dependent on the air density and the conductor radius. So, here it is the factor 1 plus 0.3 divided by root del r. It is the factor that would be multiplied into the critical disruptive voltage and we will get the visual critical disruptive voltage of corona. And everything is same, and the same thing MV, that is equal to 1 for smooth, 0.72 for local or on standard wires, 0.82 for decided corona on standard wire. Okay. Now, we are going to discuss the power loss due to the corona. Okay, how much power loss will be there? Experimental formula, here it is taken that the formation of corona is associated with the loss of power, and this loss will have a small effect on the efficiency of line. That does not have a very much effect, but have a small effect. Okay, that is countable. We cannot say that it is not countable. It is countable. This loss will have a small effect on the efficiency of line, but will not to be of sufficient importance to have any appreciable effect on the voltage regulation. The more important effect is the radio interference. It have a more important effect, that is the radio interference. And the formula given by this corona loss, that is PC equal to 243 divided by del F plus 25 root R upon D. Here F is the frequency in hertz, E is the operating voltage. Operating voltage of line, transmission line, minus E naught RMS, that is your critical disruptive voltage, square into 10 power minus 5 kilowatt per kilometer per phase. Okay. So, E is the operating voltage, but it is per phase voltage, okay, line to neutral. Okay. So, for storm weather condition, the disruptive critical voltage is to be taken 0.8 times of disruptive critical voltage, as we have discussed. Okay. So, this is the corona loss, power loss due to the corona, we can say that, or we can say that corona loss. Here we are just taking this formula 243 by del F plus 25 root R upon D E minus E RMS square. So, basically the effect of corona is 243 upon del root F plus 25 root R upon D, and here it is E minus E naught square, you can see RMS square into 10 to the power minus 5. So this is your loss. Now we are going to see that at which factor this corona loss depends. So in case of DC means F equal to 0. If you are going to compare the power loss due to corona in both cases, DC as well as AC, so we can say that PC is less in case of DC. If you are transmit the power with the help of DC, then corona loss will be lesser as comparison to the VC. Okay, means it depends upon the frequency, supply frequency. If you are increasing the frequency, the corona loss will be more. Okay. Second point, if conductor size, we are talking about conductor size R. Here you can see that if we are increasing the R, then the value of PC is going to increase, but no, actually it is not there. By this formula, you can see that if you are increasing the R, the value of PC is increasing. No, because this, if R is increasing, it means E naught RMS is also increasing, and their differences decreases, and this effect is more as comparison to this effect. Okay, so means if it is decreasing, it means PC is decreasing. So if we are increasing the radius of conductor, the corona loss will reduce. So that's why we are using bundle conductor, standard conductors, steel cord aluminum conductors. Okay. Now, talking about the value 3, del, atmospheric condition. Del as 2.73 B upon one second, just one having 273 plus T. 273 plus T. Here the B in mmHg, okay, centimeter Hg, sorry, centimeter Hg, T degree Celsius. As we notice that if B is increasing, del increasing, that reduces. If del is increasing, then PC is decreasing. So if pressure is higher, as we go for hilly areas, pressure is higher, so in that case the PC is less. And if we are on plain area, B is less, del is less, PC is more. So that depends on the weather condition, atmospheric condition, where it is planted. This transmission line is planted over there. We have discussed frequency. So as we have seen that if you are increasing the frequency, the corona loss will be more. In case of DC, the corona loss is less as comparison with the AC supply system. And the confusion part is only conductor size. If we see directly in this formula, then we can see that if we are increasing R, then PC is increasing, but it's not there. The PC depends on R and also it depends on the E naught, and the dependency of E naught is more as comparison to this factor root R upon D. So if increasing R by the formula, E naught RMS, that is your critical disruptive voltage, is increasing, and there are differences because E is fixed, it is not going to change. E is fixed, their differences decreases, that decreases the corona loss. Here we can say that the value of del, that depends on the B and T, or we can say that we can check here for higher value of T, if temperature goes on increasing, del goes on decreasing, that increases the PC, corona loss. Means higher temperature give rise to more corona loss as comparison to the lower temperature. If we are lowering the temperature, T is decreasing, then del is increasing, means del increasing, PC is decreasing. So we can see that in winter season we can have lesser corona as comparison to the summer season. Okay. So these are the factors that affect the corona, and it also causes the radio interference. Radio interferences means that the balancing of the we can say that the power system lines that goes disrupt, and the non-sinusoidal formation of current and voltage over there, that will introduce harmonics to the load, and they are going to disrupt the and further it disrupt the system. Okay. Thank you so much.